So here's the source code for the ex3 case study project. As you can see, as before, we have a couple of methods that are registered with the async tester to run asynchronously. And these truly do run asynchronously, let me tell you. The first one we're going to take a look at will be the test fraction exceptions method. And this, as I've talked about before, is going to show off a whole host of interesting RxJava observable and single methods when we walk through its code. So the purpose of this method is to use an asynchronous observable stream and a pool of threads to showcase exception handling of big fraction objects. So let's take a look and see how this works. In this particular case, we're going to use a string builder, and then we're going to go ahead and make ourselves a whole bunch of kind of helper variables. So one of these variables is called error handler. And you can see what error handler does is when it's called, it basically is going to take in a throwable and return a big fraction. And what it'll do is it'll go ahead and log what exception occurred, what error occurred, and then it's going to return 0. So no matter what the exception was, we're going to convert it to a 0. And you'll see why that's going to make sense in a second. We then have another local variable called multiply big fractions, and that's going to be passed a fraction or a big fraction. We're going to go ahead and print out a little message that says we're multiplying one fraction by a big reduced fraction. We've seen that one before. And then we're going to go ahead and do the multiplication. So that's another operation we're going to do. And that's, of course, going to run in the background, of course. And then the last local variable we have here is something called denominators. And denominators, as you can see, is just a list of integers with the values 3, 4, 2, 0, and 1. And the 0 is very important because when we use 0 as a denominator, of course, that will trigger the arithmetic exception. So the whole point of this is to get an exception to be thrown. So here is the actual code. This is the observable stream. We take the denominators list and call the from iterable method. That converts that into an observable of integers in our integer stream, which would be 3, 4, 2, 0, 1. And then for each denominator in that stream, we're going to use the flat map method. And this flat map method is going to use RxJava's flat map concurrency idiom to reduce and multiply these big fractions asynchronously within a thread pool. And the thread pool we're going to use here is the computation pool. That's the one that comes from schedulers computation. And that's meant, it's a fixed size pool that's meant for compute bound tasks. So for each denominator, for 3, 4, 2, 0, 1, we are then going to do the following thing. So this is the concurrency idiom. For each of these things, we're going to go ahead and use the denominator to create a big fraction using the observable from callable factory method. So this is going to go ahead and create a random big fraction with a random numerator and the given denominator. And when the denominator is 0, of course, this is going to throw arithmetic exception, but we'll come back to that. We're then going to use the subscribe on method to say, run that particular computation in a thread in the background. So for each denominator, we're going to schedule the processing of the subchain of calls here to run in a thread in the computations thread pool, in that fixed size thread pool. So that's very important. Each of these computations for each denominator, they're going to be done in a background thread, probably, at least conceivably a different thread, depending on how many of these there are and how many threads and cores you have in your processor. So that will then get that to run in the background. That's part of the idiom. And then we have this thing called on error return. On error return is an exception handling method. And if for some reason arithmetic expression is generated here because denominator is 0, control will transition here. And what'll happen, as you saw before, was that we convert that into a 0 and we log it, the fact that it occurred. If we don't get an exception, on error return will not be called. It'll just be skipped over. And then what we do here is no matter what happened, we go ahead and we multiply by passing in the multiply big fractions variable, and that will go ahead and perform the multiplication. So what we end up with out of all this stuff is we end up with an observable of big fractions that have all been multiplied in the background. So that's what the flat map idiom does. It runs all that code in different threads in the background. then what we do is once we've that's kind of like forking and joining, if you will. Now we have this observable that's got all this processing done. We're then going to go ahead and get rid of any big fractions that are less than or equal to 0. So anytime we had a denominator that blew up and we returned 0, we're just going to skip over those things. So we're going to ignore them. And then we're going to take all the non-zero results. So we collect all the non-zero results into an array list. And you can see we do this by making an array list. And then we give it the list add accumulator method, which is a by consumer. And that's going to go ahead and accumulate into the array list. And that array list will get returned as a single to an array list of big fractions. And then what we're going to do is we're going to call the flat map completable method. And this is a real doozy. So what we're going to do here is we're going to take that array list and we're going to say, sort and print this array list. And this is going to be really cool. But before I show you that code, what is going to happen is sort and print list is going to return a completable. And that's what's going to come back as the return value from flat map completable. So that's going to then be returned as the return value of this method way up here, test fraction exceptions, will return that completable. And that's what we'll use to tell the async tester framework, don't return until all these asynchronous computations are done. So let's go ahead and take a look at sort and print list, because this is super duper cool. So here is sort and print list. Sort and print list takes in a list of big fractions that have been multiplied and reduced concurrently. And then it goes ahead and will create a single called quicksort S, which is a single list of big fractions. And the way we do this is we use the just method on single to call quicksort on the list. And then we subscribe that to run in the scheduler's computation thread pool. And that will then go off and run in the background. And that computation will be quicksorting the list as we have another computation heap sorting the list in the background. So what this is basically doing is we're quicksorting and heap sorting in parallel in the background, asynchronously, getting back to singles. And then what we're going to do is we're going to have a little local variable that's going to display everything when we're done. We'll see that in a second. What's more important here is we then say single.amb array. And so this is amb array, which is the same as first, or first with signal in the Project Reactor framework. And it's going to take the quicksort single and the heap sort single, and whichever one finishes first, it's going to dispose of the other one, and it's going to take the results of the one that happened first. And on success, it will display those results, which, as you can see here, just goes through the sorted list and then prints out the results, appending it to the string builder that we've got. And then after we've done that, we go ahead and return ignore element. And that ignore element is going to be passed back up to the return value from flat map completable, and then that will get returned back to the ultimate caller of the whole thing. So very cool. Let's go ahead and start running these computations. They take a while to complete. So while that's going, we will go off and talk about other stuff. And then when it's done and we analyze the last method here, I'll show you what the results are.